NASA's PIXL instrument reads the chemistry of Martian rock live from the Perseverance rover up there on the planet Mars. But processing that data took 30 hours, which meant a scientist could form a hypothesis on Mars and not get the answer back on the same sol. We got that down to 10 minutes. My name is Tom. I am the founder and CEO of Concept to Cloud, and we deal with data in regulated industry, be it space tech, fintech, health tech, you name it, we deal with the data in it. We build the platforms and we really help add value for our customers where they need it most. The PIXL X-ray spectrometer literally zaps rocks on the surface of Mars, reads the data in from the X-rays and sends it back to the planet Earth. That comes through the Deep Space Network. It ends up inside of data pipelines that are built by the engineers at NASA JPL. The problem is that, of course, the data that comes back is something that comes back once. You can't patch systems on Mars. You've got to make sure it's accurate before the instrument flies. And then as that stuff comes down, you have to be able to make sure that it is in the scientist's hand as soon as possible so that they can make a decision whether or not to continue their drive or stay at the rock of interest and analyze it further using different instruments. So if you every time you use that instrument, if you had to wait 30 hours for that data to be processed, analyzed, and then a decision to be made, you're going to lose a huge amount of time from the driving around on the surface of Mars, where you could be looking at different rocks, different features, or doing different experiments. And this is something that the scientists wanted to be able to tackle so that it wasn't such a big problem once the rover became active on Mars' surface. Of course, as with a lot of these things, I keep harping on about boring tech. As with a lot of these things, the science was fine. The pipeline was really the bottleneck. Getting that data down and processing it in the way that it was processed before was gargantuanly slow. It was Excel spreadsheets. It was a lot of human cranking data out. There was a lack of automation, and that was something that we could then go and achieve for the project. So what did we do? When I arrived on that project, there was already some code in place. We decided to rebuild that and re-architect the way that it works, but we rebuilt that cloud backend to better leverage AWS services while still making it flexible, scalable, and portable, which is something that they want to be able to achieve with this project, to be able to use in different environments. At the moment, it was being used inside of AWS as part of the PIXL data processing pipeline, but there was the opportunity to then also use that same information, that same process, for different instruments back here on planet Earth. So by rebuilding that pipeline, what we did was leverage cloud components where it made sense, flexible interfaces so that the data could flow between the different components and then end up in the scientist's screen in a truly unique platform. That platform is available today. It is open source, which is a great part of that project that I was working on. And so you can visit pixlise.org and have a look at some of the screenshots. If you look at the GitHub repo, you can see the code itself. That is the code that we built that runs the data processing pipeline here on Earth. So the result of all of this, it took 30 hours of largely manual processing of data, took it down to 10 minutes. And so that's 180 times speed up. 12 weeks concept to production because the time was tight, and then iterating over it as we went on. That ended up getting us second place in NASA's Software of the Year competition in 2023, which is something that I am immensely proud of, as are the rest of the guys and girls who worked on that project over at JPL. Of course, there were some interesting issues when it comes to processing data that comes from Mars. The most pertinent being, you don't know when you've got it all. And that is truly a problem. When it comes to dealing with data that has come down, have you got all the data? When it just looks like ones and zeros, how do you know that you've got everything? And so, we work through a number of different scenarios similar to that to be able to provide a stable and effective pipeline for the scientists at NASA to make sure that we knew that they had everything that they needed in that processing pipeline, and that the data that they were looking at was the whole set for that scan. It's not as simple as it sounds, but it's something that the team really enjoyed working on. So what's the lesson for everybody here? Your bottleneck is almost never the clever algorithm. It's the boring pipeline around it. And that's just as true in any other business as it is working on space systems for NASA. If you feel like you've got a similar issue, we build critical systems for missions that cannot fail. Book a call, let's get a discovery session in the diary, and let us help you with your next mission. Bye for now.